Alright, let's look at the homework 14, problem number 5. Alright, we want to find the mass of the solid inside the cone, and z squared equals x squared plus y squared between the planes at z equals 1 and z equals 2. And the density is 1 over x squared plus y squared plus z squared. Alright, so let's do that. I'm gonna use cylindrical coordinates. Alright, so before that, maybe we should draw a picture. So it's gonna look like this. So here's the x-axis, here is the y-axis, here's the z-axis. Alright, then we have a cone, so it's gonna look like kind of like this. Alright, then we're going to cut it at z equals 1, around there, and z equals 2. So here is 1, maybe here is 2, there. Alright, so if you cut the plane at z equals 1, so here's a plane at z equals 1, and here's another plane at z equals 2. So it's going to probably look something like that. Alright, so then cross section it's going to look kind of like that. Alright, then here. Alright, then you're looking at solid here. So this is the solid. Alright. Alright. So it looks like a Reese's peanut butter cup. And then we want to find the mass of that. So mass M is equal to, so you have triple integral. Right, then volume element would be r dr d theta dz. Right, then density is this guy. So remember that the x squared plus y squared is equal to r squared. So we can put this guy right here. So this is density is 1 over r squared plus z squared. Right, then we're gonna have to figure out what the r is. Right, so I'm gonna actually look at the cross section, slice it by yz plane. So it's gonna look like this. Here is y and yz plane. Right, then the cone is going to look like, so yz plane is x equals 0. So if you plug in x equals 0 here, we get z squared is equal to y squared. So by taking the square root, we get z equals plus or minus y. Right? So we know that the cone is going to be a 45-degree line, so this is a y equals z equals y, same thing, and then z equals negative y. Alright, then you're going from z equals 1 and z equals 2. Right, so we have this region. Right, so for fixed, so I'm gonna fix theta and z. Right, then r is gonna be, so for a fixed z value, say let's say this is z, so r is gonna start from here and ends there. Right, so looks like r is gonna start from 0, so that's pretty obvious there. Right, then all the way to the cone. Right, so since this is z equals y, so if this is z right here, so this is z, then this length is also z there, right? So r is going to start from 0 to z, right? Then after that, we can swing it all the way around. So so maybe you should look at it in a 3D picture. So here, so we have this much. Then after that, we can rotate this all the way around, so it's gonna go like this, so that we can cover the disk at the height that z there, right? To do that, all we have to do is take theta, start from 0, then 360 degrees, so 2 pi. Alright, and after that, we can stack these disks starting from the very bottom, which is starting at 0, and all the way up to z equals 2. So we have z equals 1 to z equals 2. Right? Then you just need to evaluate this. Right? I will let you guys evaluate this. Right? That's it. I hope that this will get you going.